Our next talk is going to be by Stefan Graber. He's the project leader of the LexD project and LexC project, which incidentally has 10 years reached right now. And he's going to talk about turning physical systems into containers.
All right, me again. All right, so very briefly, I'm Stefan Graber, I'm the project leader for LXC and LexD. As Christian said, we've just reached 10 years now for the LXC project. So we've been doing containers on upstream Linux way before everyone else. So just today I'm going to be talking about LexD. Very briefly, LexD manages system containers. Our definition of a system container is that you run an entire Linux distro. They are extremely similar to virtual machines, with the one tiny detail that they do share the kernel with the host. Feature-wise, pretty much identical to virtual machines. They're super light, no virtualization extension or any of that stuff is needed. Great way of making systems faster by removing unneeded overhead when you're running Linux on Linux. Now, for LXD itself, well, it's been, like 3 years we've been working on this thing now. It's effectively the next step of user experience for the LXC project. It is a system container manager with a REST API, simple command line utility. It is network aware, so you can drive multiple daemons and move stuff around, as David showed earlier. It's secure in that we use every single kernel security features at the same time. We default to using user namespaces. We've done the work to implement user namespaces back in the kernel originally. We've done a lot of kernel work here and there to add extra namespaces. John presented the work on the LSM support for LXD to make it possible to load down APAMO profiles inside the container that's different from the host profile. Like we have just about every security feature you can think of. It's very scalable. It's the exact same tooling you run on your laptop as you would run on a pretty big machine. We've got some clustering work coming up that Free will be talking about later this afternoon. But right now, what we're interested in is moving a physical system into a container. So, let me get that. That looks reasonably big. I think it might actually be overflowing at the bottom, but that's fine. I don't have that much text. Hopefully it's going to still fit. All right, so first thing first, I've got two virtual machines running, VM06, VM07. VM06 is a Ubuntu VM that's fresh and it's got nothing, so just install LXD real quick on that. It's not running here for obvious reasons. So it's quite a bit, because otherwise the loading would be slightly annoying. So we're going to use a default that creates a ZFS storage pool for containers that creates a new bridge for the network. Actually, I wanted to change an option. Oh, I guess I'll just do it by hand. We need to set a just password. Just password. All right. And then tell it to please listen on the network. There we go. So got a LXD that's running with no container in it, no nothing right now, but it is listening on the network, and I can use that password. Now, let's move to another system. This one's a bit different. This thing is a CentOS 7 system. The system is currently running an Apache server that you will not see. Let me just try to fix that thing a bit. There we go. That's much better. So, so you've got an HTTP server running here. There's a process list at the bottom of that. Pretty much nothing particularly fancy. We can just touch a file just for kicks. There we go. And then we get to run a command line tool I wrote called LXD-P2C. So that's physical to container. Kind of similar, like the same concept as P2V, which was done back in the VMware days, like moving all your physical systems into virtual machines. So in this case, you could actually stream your running system. You could point it at something else, but in this case, I'm just streaming /. So I'm giving it the URL endpoint for that LXD I just set up, giving it the container name I want. It's just creating a new certificate. There we go. Now it shows me the fingerprint of the server. I'm assuming it's right. Enter that demo password. And I will just wait a bit for the entire file system to be transferred. Thankfully, it's a new CentOS install, so it's not going to take particularly long. It does some stuff to try and prevent changes. So it basically creates a new mount namespace. It mounts just the paths you need. So it's not going to rsync like your /proc or /sys or any of that stuff. If you've got multiple mounts, you can set that. So you could do / and then /home if /home is a different mount. And they will be stacked in a clean mount namespace, and then that result will be streamed to the container. Anyway, we see it's happened. So now let's go back to our other system. And we can see we've got a new container here. It's called CentOS VM07. It's the name we gave it. Let's start this thing. First start takes a tiny bit longer because LXD using the user namespace means that the file system it received wasn't shifted to the user IDs and GIDs of the user namespace. So it does that on first startup. So it took like a second to just remap the entire file system. Now if I get the shell inside it, we see it's VM07. If I look at the process list, we've got Apache running. And if I look at /root, well, we've got my blah file in there. So that's how you do it. Now, why? Like, why would you actually do that? I mean, it's nice and cool and everything, but why would you do that? So, the usual use case, like companies do have tend to have a large number of old systems that are running there doing something. They don't really know why, but if they turn it off, it will probably break something. They don't want to deal with that. Those systems use quite a bit of rack space, are usually pretty bad at power management. And so it might make sense to move them to containers because then you can slam like, I don't know, 200 of those on one machine and save yourself like 4 racks. That'd be neat. But you could also use virtual machines for that. Now, why would you want to move virtual machines onto containers? Well, if your VM is CPU bound and uses all its CPU all the time, you probably don't. It's fine to run that as a virtual machine. Now, if your VM is idle 99% of the time, which is quite often the case with those kind of workloads, VMs are not very, very good at being idle. They will still trigger interrupts. They will still use CPU times. Like, did you recently run 2,000 VMs on one server? Because we can do it with containers just fine, but VMs, not so much. You usually tend to have, you can run 100 on very beefy hosts. You might be able to run 200, but that's like mostly idle VMs, just still using a lot of your resources. It's perfectly reasonable if the VM is very busy, but if you're looking at a Linux on Linux use case with a VM and it's idle, you can pack a crap ton of those into containers, which you can do with VMs. The other thing that came up pretty recently, because Meltdown, Spectre, all that mess, we unfortunately have a number of people that are running completely end-of-life systems. They're running CentOS 3, CentOS 4, those kind of systems with production workloads. Obviously, they're not going to get a Spectre or Meltdown fix for the kernel because it's been end of life for like 2 to 4 years. But if they do that, now that CentOS system we were seeing, if I move back here, well, it is CentOS running, but if I look at the kernel, it's an Ubuntu kernel. It's running the Ubuntu 4.4 kernel, which is patched for Meltdown and Spectre. So say you move your CentOS 3 container over to a machine that's got a fixed kernel and your workload still works fine with that, well, you just fixed yourself a pretty nasty security issue in the process. Will not work for everything. Some workloads will depend on the crazy old kernel that came with the system, but for a lot of workloads it will work just fine. To show that some more, I've got on my local system, I've got some containers running there. Such as a it didn't even have redash release back then. Whoops. So CentOS 3, I think you can still run yum because the archive still exists. So yeah, you can run yum update. There's not going to be anything, but technically it's there. You could install packages and stuff. And that is quite happily running on a 4.15 kernel right now. And the exact same is true of CentOS 4. Exact same thing. The container is running, and it's not really doing much, but it's definitely running. We did try to go as far back as we possibly could with that. Didn't work so well for us because at some point, well, we tried running Slackware 1. And the problem with Slackware 1 was that it predates the ELF format. And it turns out you can't actually run an A.out binary format on a 64-bit Intel system. You could on a 32-bit system. So 32-bit with the right kernel option, you can actually run a Slackware 1 container on it. But yeah, if you still have that, then maybe you've got other problems. Anyway, I believe I'm running out of time, and that's the second demo I just did. That's just LXD is written in Go. You can find it on GitHub. There's no CLA, no nothing. You can just contribute to it if you want. It's translated and all that stuff. And we might have like a minute for question, maybe. Otherwise, we've got stickers and swag and stuff in front there. You might want to take some of that on the way out. Questions? There's one there.
How do you manage converging with high I/O?
How do we manage what with high I/O? Sorry.
If your system to be P2C has very high disk I/O.
Oh, so if it's very busy at the time you're trying to stream it? Yeah, don't do that. Effectively. I mean, we expect the P2C tool will let you do it against the VM image if you want at some point, so that you don't have your system changing constantly while it's going on. Yeah, right now it's pretty much turn all your daemons off, then P2C works fine. If it's very busy at the time, then you're going to get some snapshot of something, but you might not be happy with the result. Yes.
Okay, wait.
Which distros do you test?
So what did we try? We tried pretty much everything that LXD supports right now, and we support something like 15 distros or so. So you can do CentOS, Slackware, Gentoo, Fedora, OpenSUSE, Playmo, which is like a Japanese Slackware derivative, I guess. Whatever we've got right now, they all work fine. You do get some weird issues. Like we noticed that back on CentOS 3, a bunch of utilities were expecting that proc meminfo would fit in 1 key of memory, otherwise it's a fault. Turns out it doesn't fit in 1 key of memory anymore. So for those kind of things, you need some tweaks. Thankfully, we do have a fuse file system that overlays on top of proc that can fix those things very easily. So we just remove all the fields that are recent and that CentOS 3 doesn't know anyway. And it works fine. But there's some amount of fiddling that might be needed here and there, but by and large, things work pretty well. And that's it. We're going to switch to the next speaker. So thank you very much.
Thanks.